so now we're going to start the main part of the course, which is proving the theorems of calculus, single variable calculus. And after the first chapter's warm-up. So the plot now is that you leave your job at the wire company, and you get a new job, maybe a better job at this math institute, where your job, at first at least, is to evaluate limits. Okay, so you're going to be evaluating limits, and more importantly than evaluating limits, proving that the limits are what you say that they are. Okay? Now, you don't know why you got this job, but somehow your employer was impressed by your job-related experience with the wire. But so you don't really know anything about proving things about limits, though you have some intuitive idea, right? So, all right, so intuitively, what does it mean? Okay, now just intuitively, just tell me, no stress, just whatever. You know, basically, I want some intuitive definition that we can make more precise. What does it mean to you that the limit is for? Yes?
X is close to 2, then x squared is probably close to 4.
Okay, well, you're all right. That's already more than I was expecting. If X is close to 2, X squared is, let's just say close to 4. Okay? Okay. Now, okay. You said tolerably close. We have to think about that. So is this completely accurate, or as on the intuitive level? Again, it's very imprecise. Okay. Yes.
Like X approaches to X squared.
Okay. Okay, now this definition is, on the one hand, not precise enough, but also there's something a little bit wrong with it. Anybody tell what's wrong? Even on the very intuitive level. Okay, so there's a little, let's take this function here. We'll come back to this later. Let's say g of x is equal to x squared for x not equal to, and 3 for x equal to. Okay, so what is the limit of x goes to g of x? Let me grab the function. Looks like this. The limit is 4. Good, you remember, right? Okay, you learned that it doesn't. So what do I have to add to this little intuitive definition to make it make sense? So what's the point here? I mean, isn't 2 close to 2? You told me if x is close to 2, then the function has to be close to the limit, right? Isn't 2 close to 2? How come the function isn't close to the limit?
So x is close but not equal to.
Okay, right. If x is close but unequal, that's very important. Or as x approaches 2, how would you say it?
Does not reach.
That's the way to reach. Without reaching. that's a good intuitive definition of them, right? Now, okay, so you get to your new job, you don't really know what to expect, and you meet your new employee. His name is Mr. Epsilon. You just have to imagine he's this small but highly energetic Greek who anyhow, you'll get to know him very well. And so, anyhow, he gets right down to business and asks you to prove this limit x squared as x goes to x squared is 4, right? And so you tell him this, right? And then, this is not, you just say, well, he asked you to prove this. And you say, well, I don't know what proof is in this context, but intuitively this is what it means, right? Okay. And he says, okay. But, this isn't a proof, it's too imprecise, right? So he says, okay. In that case, okay, now, this is very important. He says, in that case, it must be so that if x is close enough to 2, the distance from x squared to 4 is less than, let's say, 1. All right, let's say 1, okay? All right. So can you prove that? Now, this looks really pretty familiar now, right? If x, it's true that if x is close enough. If x is close to 2, then x squared is close to 4. Okay, then it must be true that x is close enough to 2. The distance from x squared to 4 is less than 1, right? Okay, so how would we prove this in this terms? We know the procedure, right? First of all, so what do you have to do?
Factor x squared minus 4.
We factor out to x squared minus 4, and that's to x minus 2, and that's x plus 2. And we know what? If x is close enough to 2, after x plus 2, so how big would that be? At most? This is absolute x plus 2, right? 5, right? Remember the trick? If x equals 2, it's 4, right? If x is close enough to 2, it's at most 5, right? Okay. And then if x is close enough to 2, the other factor